So for this video, we are going to go over how to do an avoidance MoBoard. So your problem is you are on a course 090 degrees true at 15 knots. At time 0728, a contact bears 135 degrees true at 9,000 yards. At time 0734, the same contact bears 140 degrees true at 7,000 yards. The CO tells you to avoid the contact by coming left, increasing CPA to 5,000 yards, and increasing your speed to 20 knots. So first thing that we do is we always want to plot our knowns. So let's go ahead and plot everything that we know from the problem. We know that we are on a course of 090 at 15 knots. So we know our ER vector. We also know the bearing and range of that maneuvering ship or that contact. So looking at the numbers of 9,000 yards and 7,000 yards, I'm going to go ahead and decide to use that 1-to-1 scale. So I'm going to circle my 0 up here to remind myself throughout the duration of this problem that I am using the 1-to-1 scale. So I'm going to go ahead and plot M1, or that initial sighting of the contact, down a bearing of 135 at 9,000 yards. And then I'm going to plot M2, which is that second sighting of the contact, down a bearing of 140 degrees true at 7,000 yards, which will put me right here. So now I have M1 and M2. Next thing that I want to do is write out all of my unknowns, or what I'm going to be solving for during this problem. I'm going to be solving for my DRM, or direction of relative motion, MRM, or the measure of relative motion, SRM, or my speed of relative motion, my EM vector, and from the EM vector, I'm able to find the maneuvering ship's true course and true speed. So first things first, I'm going to go ahead and connect my M1 to M2. By doing that, I am going to figure out the line of relative motion of this particular maneuvering vessel. I then want to take my reams, parallel that up to the center of the MoBoard to figure out my DRM, and then again to the tip of my ER vector. That's going to give me my RM line of possibilities. Now I want to go through and label all of my lines. This blue line, or excuse me, the first line here is my LRM. So that's showing me that my contact is moving this way. So I'm going to draw a little arrow here just as a reminder of which direction my contact is moving. Next, I have my DRM. Then I have my RM, line of possibilities. So from here, from this line, I've already figured out my first unknown. So I found my DRM to be down a bearing of 300 degrees true. Make sure that you are always including the proper units and labeling all of the pieces of your MoBoard. Next thing that I'm going to be looking for is my MRM, my measure of relative motion. So I'm going to be measuring the distance between M1 and M2. I'm going to use my dividers for that. I'm going to bring that over to the 1-to-1 scale. That's going to give me a distance of 2,200 yards. So what that means is, from that initial sighting of that maneuvering ship to the second sighting of that maneuvering ship, that contact moved a total of 2,200 yards in a time of 6 minutes. Next unknown that we're looking for is our SRM. So your SRM is your speed of relative motion. So using our time, speed, distance equation, we remember that if we're looking for speed, we need to know a distance and a time, both of which we already know. We know the distance from solving for our MRM, which was 2,200 yards. So I'm going to come down to my nomogram and I'm going to make a mark at the 2,200 yard mark, or 2,200 yard distance. I already know my time to be 6 minutes. That came from the problem. So I'm going to make a mark there. All I'm going to do next is take my weaves. I'm going to connect those two dots, and I'm going to carry it down to the very bottom line, which is my speed line. And that's gonna give me a speed of 10.5 knots. So I know that my speed of relative motion is 10.5 knots. So now I want to measure out that speed of 10.5 knots using my 5-to-1 scale. Remember, your 5-to-1 scale is always going to be used for speeds. So I'm gonna take my dividers, bring this over to my 5-to-1 scale, and I am going to measure out 10.5. I'm then gonna take my dividers, bring them over to my RM line of possibilities. I'm going to just make a mark on that line. So this point here becomes my point M. So now we have E, R, and M. So now we're able to complete our speed triangle. All we want to do to complete our speed triangle is line up the center through point M, close that triangle, and then we want to make a little mark over here at the end of our bearing circle. So now we have our EM vector. And remember, from our EM vector, we're able to find the maneuvering ship's true course and true speed. If we follow this EM vector all the way out to the end of our bearing ring, we know that, or we are able to figure out that the maneuvering ship's true course is 047 degrees true. If we want to find their speed, all we have to do is take our dividers. We're going to measure out the length of the EM vector. Bring that over to our speed scale. That's going to give us a speed of 8 knots. So now we've solved the contact tracking portion of the avoidance MoBoard. So now we know exactly what this maneuvering ship is doing and what we can expect from them. So at this point, we want to go ahead and apply the constraints that the CO gave to us so that we can open the CPA up to a point that the CO feels comfortable. So the first constraint that we are going to plot out is going to be the CPA of 5,000 yards. So all we're going to do is we are going to take our dividers, we are going to open them up to a distance of 5,000 yards, and we are just going to come around and we are going to plot a circle around our ship that is showing that 5,000 yard ring. So that's what this outer circle is. And I'm going to label that very small, and it just says 5,000 yards, just to remind me that this ring is representing 5,000 yards. Next constraint that I'm going to apply is the speed of 20 knots. So I'm going to come over to my speed scale, set my dividers to 20 knots. Then I'm going to draw that circle around my ship to show that 20 knots that the CO said that I have to stay, or I have to increase my speed to. I'm going to label that circle as 20 knots. The third constraint that was given to us was the direction that the CO wants us to steer. So if my ship is traveling this way and the CO wants me to come left, that means that I'm going to turn this way. So what I'm going to do is go ahead and highlight the portion of the circle that all of my solutions can come from. So this highlighted portion is highlighting that constraint of becoming left. So now, with everything that is on my ship, I want to figure, everything that I have labeled on my MoBoard, I want to figure out what new course and what new speed I need to drive so that my CPA will meet the constraints that were given by the commanding officer. So what I need to figure out is a new LRM for this maneuvering ship. And I do that by trial and error. So the first thing I'm gonna do is I'm gonna take my second initial sighting of that ship, M2, and I'm going to line up my dividers, my weems with M2, and I am going to draw a line tangent to that outer circle, or that circle that's representing that 5,000 yards of CPA. I'm then going to take my dividers, my weems, parallel that to the tip of my EM vector, and I'm going to draw a line in the opposite direction that I went for that LRM. So from M2 to our tangent to the circle, I went up, I paralleled that over, and then I drew my line down. So this red line is representing all of the possibilities that R prime could be on. But if we look at this red line, we see that none of these possibilities would meet this constraint, right? So we know that this is not a viable LRM. So I'm just gonna go ahead and erase that so that I can just get it off of my MoBoard, and it's one less line that's gonna be there to confuse me. So now I'm gonna try out my second solution. So I'm gonna go from M2, and I'm gonna draw a line tangent to my CPA ring of 5,000 yards. Then I'm gonna come up to the tip of my EM vector. I'm going to draw that line in the opposite direction. And looking at this line, I see that it does, in fact, cross over one of my constraints. So this line here, I'm gonna go ahead and label as my R prime M LOP. And all that is just reminding me that somewhere along this line, I'm gonna find my R prime. Now this line down here, I'm just gonna go ahead and label as my LRM prime, just so that I don't lose track of my lines. And all that's saying is this is that new line of relative motion that I'm gonna be basing all of my other solutions off of. So as before, we're just gonna take this LRM, parallel this up to the center of my MoBoard. That's gonna give us a new direction of relative motion. So I'm gonna label this second line here as my DRM prime, and this is gonna come in handy again later. So now I have my RM line of possibilities. So now I wanna see, where does this line intersect with the given constraints? It intersects at this point. So this point here, where this line is intersecting those constraints, that point becomes my R prime. So I'm gonna go ahead and label that as R prime. Now I'm just gonna connect E to R prime, give me a new speed triangle. I'm gonna make the mark out here on the bearing ring. So now for my new ER, so my new course, my new speed, finding my new course to be 078 degrees true, and the speed is going to be 20 knots. We know that because it was given in the problem, but if you want to double check it, all you have to do is measure out the length of your new ER prime vector, bring that over to your speed scale, and you should get a speed of 20 knots. So now we have the new course and speed that we have to travel to meet the CPA constraints that were given by the captain. But now we want to figure out what our new CPA bearing, range, and time is going to be. So we can find that that point of CPA in two different ways. First way would be the plus or minus 90 from the DRM, or you can look at it visually and see where this particular LRM crosses this CPA bearing, CPA range of 5,000 yards. I'm gonna do the addition, or the subtraction version. So if my new DRM is 270, I'm gonna call it 273 degrees true. If I were to subtract 90 from that, it should give me a bearing of 183 degrees. So I found my CPA bearing to be 183 degrees true, or 183 degrees true. If I were to eyeball it, it would be at this point. We're gonna line that up. That puts me at 183.5 degrees true, so that will be within tolerance for testing purposes. So now I have my CPA prime bearing. Now I need to figure out the range. You can figure out the range one of two ways. You can either just measure from the center, from where your ship is, to the actual point of CPA, which is 5,000 yards, or you can think back to the original problem where the captain told you to open your CPA range up to 5,000 yards. Either way works. Now we want to figure out the time. So we are going to do that by finding the distance from M2 to point of CPA. So that's gonna give us an MRM prime, and I'm gonna go ahead and label that this way. MRM prime happens to be 5,000 yards. I'm gonna come down to my nomogram, plot out that 5,000 yards. If I'm looking for time, that means I need a speed. So I need to figure out what my SRM prime is. So I do that by measuring the distance between R prime and M. Bring that over to my speed scale. I get an SRM prime of 14.5 knots. Gonna come down to my speed scale, make a line there at the 14.5 knots. Then I'm going to connect those dots. It's gonna give me a time of 10.5 minutes. So now we have solved our avoidance MoBoard. So we know that if we were to open the CPA up to 5,000 yards and increase speed by 20 knots and come left, our new course that we have to drive would be 078 degrees true at a speed of 20 knots, and that is going to change our CPA with this maneuvering ship to a bearing of 183 degrees true, a range of 5,000 yards, and it's gonna take us 10.5 minutes to CPA them.